Hello and welcome to the Quick Start tutorial series for Rhino3DPRINT 2015 by Mexsoft. Today we'll be working with an STL file to create a cavity block. We will perform the following basic steps to complete this tutorial. First, we will launch Rhino3DPRINT and then open the STL file. Then, we'll diagnose the mesh for possible problems. We'll use Stitch and Close to combine and fix the mesh. Then, we'll use the Reduce tool to simplify the mesh. After that, we'll create a box for the cavity block. Finally, we'll subtract the mesh from the box to create the cavity. Let's begin by launching the Rhino3DPRINT module. From the main menu, select Rhino3DPRINT and then Browser from the drop-down menu. Docked on the left, you will see the Rhino3DPRINT browser. There is a ribbon bar at the top with 5 tabs. The Create tab contains Mesh Creation Tools. The Model tab contains Mesh Editing Tools. The Inspect and Modify tab contains Analysis and additional editing tools. The Repair tab contains various tools for fixing your mesh model. The 3D Print tab contains tools for fitting, checking, and exporting your mesh to a 3D printer. For now, let's select the Create tab. Now, let's load the STL model for this tutorial. From the Rhino Standard toolbar, select the folder icon. Find the part file named carmodel.stl located in the Quick Start folder and then pick Open. From the STL Import Options dialog, we'll check the box for Split Disjoint Meshes. We'll set the units to inches and then pick OK. From the browser, we see that this model contains over 300 individual mesh objects. Now select a perspective view to work in. From the Rhino Standard toolbar, select Shaded Viewport to change to a shaded display. From the Rhino Display Properties tab, make sure you uncheck Mesh Wires so we can view the model more clearly. The first thing we want to do is perform some diagnostics. From the browser, select the Repair tab and then the Diagnose tool. Now window select the entire mesh model and then press Enter. The Diagnose dialog will appear below the browser. Using the default selections, pick the Run Checks button. We see that 3 sets of checks are performed. These include edges, triangles, and vertices. The results of each check are color-coded for easy recognition on the mesh model. For example, Diagnose found over 25,000 open edges, which are assigned the color red by default. For now, we'll pick the Cancel icon to close the Diagnose dialog. We can fix the open edges quickly. From the browser, select the Repair tab and then the Stitch and Close tool. Now window select the entire mesh model again and press Enter. The mesh is then repaired automatically. Notice in the browser that there is now only one mesh in the data tree. Again, from the Repair tab, select the Diagnose tool. Now window select the entire mesh model again and then press Enter. Use the default selections again and then pick the Run Checks button. We see that we now have 0 open edges. Pick the Cancel icon to close the Diagnose dialog. Now that we have only one mesh, let's simplify it some before moving on. From the browser, select the Inspect and Modify tab and then select Reduce. Select the mesh and then press Enter to display the Reduce dialog. We'll adjust the slider to reduce the mesh by a percentage of the total facet triangle count. In this case, we'll set it to 25% and then pick Reduce. With the mesh selected in the browser data tree, we now see that the total number of facet triangles is reduced to approximately 100,000. Next, we'll create our cavity block. First, we'll go to the Rhino Standard toolbar and select 4 viewports. Then, from the Create tab of the browser, we select Box. we want to pick 2 diagonal points to define the base of the box. First though, from the Rhino status bar, select Grid Snap, and then activate the right view to work in. For the first corner of the base, we select a grid point that is above and on the center line of the mesh. For the second corner of the base, we select a grid point that is below and to the right of the mesh, making sure that half of the mesh is completely enclosed by the base of the box. Now, a third point is needed to define the height of the box. For this, we switch to the top view and select a grid point that is behind and to the right of the mesh. Again, making sure that half of the mesh is completely enclosed by the height of the box. Now we activate the perspective view to see the box clearly. To create our cavity block, we will subtract the mesh from the box we just created. In the browser, we'll switch to the Model tab and then pick Subtract. Notice that the command prompt says, Select Mesh Set to subtract from. For this, we select the box, and then press Enter. Now the prompt says, Select Mesh Set to subtract. For this, we select the mesh and then press Enter to see the results. This completes Chapter 3 of the Quick Start tutorial for Rhino3DPRINT 2015 by Mexsoft. For further assistance, you can visit the online help supplied with the program or visit www.mexsoft.com for additional tutorials. Thank you.